section 4.6. This will be right triangles, so it'll be stuff specifically for right triangles, kind of like the section on isosceles triangles was. It's just going to be specific things attached to that. Okay, so a few definitions here for right triangles. Like you've seen this guy in the middle. We're not going to do that yet, but it's coming. All right, parts of the right triangle that are important. Obviously, a right angle has to be present, so if there's not a right angle, we can't use any of this today. Right triangles have two legs. Those are the perpendicular sides. And then the longest side of the right triangle is called the hypotenuse. And it will always be the longest side. Alright, so this goes along with, how we have side, 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 and side, angle, side, angle, and angle, angle, side. So this one is the fifth one in the series, and I've added it to the board already. So this one's saying if they are right triangles, and you have the hypotenuse and a leg congruent in both triangles, then those triangles are congruent by HL. This will look like angle side side, but obviously we can't do that one. So we're going to use HL, but it has to be right angles. If there's no right angles, then we can't do this. Alright, we're not going to do that proof. Alright, so let's jump to this one and we'll try to use this a little bit. Okay. So, first step is to write the given. So AD is a perpendicular bisector of CE, and CD is congruent to EA. And that's given. Alright, then we need to go through, we need to mark on the picture. We've got CD is equal to EA, so we're going to mark that on the picture. Everything else has to be proved before we can mark it on the picture. So first thing I see is right here in the middle. Those are vertical angles, right? So we can say angle ABE is congruent to angle DBC by the vertical angles theorem. Alright, then also they say that that is a perpendicular bisector of CE. So first thing that tells me is this perpendicular thing. That means there's right angles going on here and here, right? So angle DBC equals 90 and angle ABE equals 90. So we may have not even needed to say they were vertical angles, but it's there. Alright, this is by definition perpendicular. Then that gives us the right angles, and we know they're congruent as well, so we can use them either way. Also, we have that it's a bisector of CE, so that means that this side and this side are equal. So CB is congruent to EB by definition bisector. Alright, so looking at your triangles, they have a right angle, they have a leg, and they have a hypotenuse. So the triangles are congruent. By HL. Okay? And that's how that theorem works. So if you get down to where you think you have your triangles congruent, you look at them, you see angle side side with the angle being a right angle, then you can use HL. Alright, let's try another one of these. First step, angle W and angle K are right angles. And WJ is congruent to KZ. All given. So W is a right angle, K is a right angle, and then WJ is congruent to KZ. Alright, so pause the video, look at it for a minute, see if you can figure out what this is, and then come back when you think you've got the proof worked. Okay, so obviously in the middle we have a reflexive, so we can say JZ is congruent to ZJ by reflexive. Okay, and then looking at your triangles, you've got angle side side. This is right angle, and then a side and a side. That's HL. So we can do triangle JWZ is congruent to triangle ZKJ by HL. Alright, these last two proofs I'm going to leave and let you work them yourself. And if you think you've got it and you'd like me to check it, then let me know. Show me in class, and I can help you figure out whether you've got them correct or not. Okay?